This is Mr. Martin. These are the video notes for section 10.6 for Geometry Honors. We're going to look at four theorems, still talking about circles. So for Theorem 89, we've got two inscribed or tangent chord angles intercept the same arc, then they are congruent. So we could have a bunch of different pictures for this. So let's talk about two inscribed angles first. So here's my circle, and I'm going to draw an inscribed angle. I'm going to call that angle 1, and here's my arc AB. So angle 1 intercepts arc AB. Now if I draw another inscribed angle that also intercepts that arc, here's another angle, I'll call that angle 2. Angle 1 is congruent to angle 2 since they intercept arc AB. Okay, if they intercept the same arc, then they are congruent. All right, so basically any inscribed angle around this whole circle that would intercept arc AB would be congruent to 1 and also congruent to 2. So let's take a look at tangent chord angle. This one can get a little bit tricky looking at the picture. So here's my chord, and then I'm going to draw in my tangent. So here's my tangent chord angle. We'll call it ABC. All right, so angle ABC intercepts arc AB. I'm going to draw that in red here. So here's the arc that's being intercepted. Sometimes that's the hard part to see. Now if I draw another tangent chord angle using the same chord, I'm going to draw another tangent over here. We'll call that D. I've got angle CBA intercepts arc AB, and I've also got angle DAB intercepts arc AB. Since they intercept the same arc, therefore angle CBA is going to be congruent to angle DAB. All right, so here's a couple examples. We've got inscribed angles in the first example. We've got tangent chord angles in the second example. If they intercept the same arc, then they are congruent. All right, now for theorem 90, not sure what's going on here, but that's okay. If two inscribed angles or tangent chord angles intercept congruent arcs, okay, so now instead of intercepting the same arc, they're just going to intercept congruent arcs. So let's take a look at, we'll just look at one example here for inscribed angles. So here's angle 1, it's an inscribed angle. And here's angle 2, it's also an inscribed angle. We've got arc AB, we've got arc CD. So if arc AB is congruent to arc CD, then angle 1 would be congruent to angle 2. Alright, so this is just an example of the inscribed angles. It would also work with tangent chord angles, so keep that in mind. And I think we kind of already knew these. We're just formalizing them with theorems. Alright, theorem 91. This is also something that we kind of have figured out already, but we'll formalize it again. So if an angle is inscribed in a semicircle, then it is a right angle. So again, if you're not sure what it means to be inscribed in a semicircle, I'm going to draw in a diameter here. So now I have two semicircles. So any angle that I would draw that intercepts the circle at the ends of this diameter, we would say is inscribed in a semicircle. So if I draw this angle here, since the angle goes through the endpoints of the diameter, it's inscribed in the semicircle. So, and we know that this is going to be 180 degrees, and we know that an inscribed angle is half its intercepted arc, so we know that's got to be 90. So that's just a quick informal verbal proof. So really I could draw any angle in this top half of the circle. It would work in the bottom half also, and it would be a right angle. So there's a right angle. Here's another inscribed angle that is inscribed in the semicircle, so that would also be a right angle. All right? And this is going to be a useful property for us to keep in mind. If you see that an angle is inscribed in a semicircle, you know it's got to be a right angle. And once we know it's a right angle, we've got right triangles, and we have all our different methods for solving right triangles. All right, theorem 92, the sum of the measures of a tangent-tangent angle and its minor arc is 180. So here's what we're looking at. We've got our circle. We've got a point outside the circle, so we're going to draw tangents to the circle. We'll call this angle 1. We'll call this point A. We'll call this point B. So our theorem says that the measure of the tangent-tangent angle, so the measure of angle 1 plus the measure, because these 2 points A and B divide the circle into 2 arcs, so the minor arc would be arc AB, the major arc would be the rest of that. I'd have to put another point there to name it, plus the measure of arc AB is going to equal 180. All right, so the proof of this is fairly straightforward. If I put in the center and I connect the center to A, we know what kind of angle that makes. The radius is perpendicular to the tangent line or segment. And then I'm going to draw this in, and I know that's going to be a right angle. So I've got this kite, and the kite is a quadrilateral, and I know that the 4 angles of this kite have to add up to, let's make this P, have to add up to 360. So angle A plus angle P plus angle B plus angle 1 is going to have to be 360. And since I know that A and B are 90, if I subtract out both of those 90s, then I know that angle 1 and angle P have to be 180. And since angle P and arc AB have the same measure, all right, so let's just write out a quick proof here. Proof. So I know that angle 1 plus angle A plus angle P plus angle B is equal to 360. That's because it's quadrilateral. And I know that angle A plus angle B is 180 because those are right angles. All right, so if I subtract out angle A plus, or angle B, and then subtract out 180 on that side because that's what it equals, I get that angle 1 plus angle P is equal to 180. And I know that the measure of angle P is equal to the measure of arc AB. Therefore, measure of angle 1 plus the measure of arc AB is equal to 180. So if you have a question about this quick proof, let me know. It's pretty straightforward. But again, I went through it quickly. Make sure you ask me questions. All right, so let's take a look at a couple quick examples for this last theorem, theorem 92. For the first example, my tangent angle is V, and the minor arc associated with it 100, and we know that the measure of angle V plus arc UW, the measure of arc UW is 180. That's what our theorem says, that the tangent angle plus the minor arc associated with it is 180. So then I get the measure of angle V plus 100 is equal to 180. Therefore, the measure of angle V is equal to 80. All right, so I'm showing all the work, but it's fairly obvious that those two have to add up to 180. Once you use this a couple of times, you'll get better at it. All right, number two, another fairly short example. We just have one more step. So we know that the measure of angle F plus the measure of arc GE has to be 180, so we just need to find GE. The measure of arc GE has to be 360 minus 225. So we get 135. So then the measure of angle F is going to be 180 minus 135, or 45 degrees. All right, so that's it for this video. If you have any questions, make sure you write them down so you don't forget, and ask me. If you're watching the video in class, go ahead and pause the video at any time and ask those questions. So we'll see you next time.